Hello, my name is David Thibodeau, and today I'm going to talk about the capture window, the params window, and the sequencer for the ADAU1452 or the Sigma 300 family of parts. And we'll talk about a few other things along the way, as I usually do. Um, so what I'd like, hardware, what am I doing hardware-wise? Well, I'm using the Rev B board, ADAU1452 Rev B board. Um, and obviously the USB-I is connected to it as well, USB interface, and that all comes together with the kit. And I have input on channel 0 and 1 and output on output 0 and 1, and that's about it. We're not going to get too involved in the hardware today. Um, so, so that means I can probably get rid of that little inset there. Perfect. Let's start with the project that we built on the first video for the 1452s, and that's the basic input-output program. Input, output, mute, meters, kind of the basic things you need. And what I'm going to show you first here, by the way, is little things I didn't mention in the last one, because a lot of times it's nice to like line these things up. So you can lasso, and there's some lineup boxes here, which allows you to make them line up, which always is a nice thing to do. Look at that. Beautiful. Much better. Um, we'll move the meters over here. And what I'm going to do is insert an EQ block because I want to have other things to see. Um, so let's go up to filters and second order double precision. In this DSP, it's you don't lose MIPS by doing double precision. It's really very great to use. I almost always use double precision. And so pop in the filter here. Come on. And we have the ability to grow algorithm, but we can grow a section or a channel. So you can have cascaded filter sections in that object, which is a little bit more efficient than dropping in multiple blocks. So I would grow the section if you wanted more than one section. But right now I just want one. I just want to make it stereo. So we'll make this one filter stereo um, and connect it in right here. It's a good place to do. Uh, and right now I really don't care what the filter is. Um, well, maybe I should care about it. It comes up with a parametric default. No, actually, this will be fine. You can select shelving, high pass, low pass, band passes. You can kind of see the choices here. Um, the IR coefficient is nice because it lets you put in your own coefficients. So anyhow, but that's not the topic of the discussion here today. We want to look at the um, capture window, the params window, and of course the sequencer a little bit. So I'm going to clear this out, this big old red X. So you saw I expanded the capture window. If it's not there, you get it up here on the far right there of these icons. One of them says capture window. Of course, I think you can go over to view, but who uses these things anymore? Yes, you can. It's right there, capture window. Oh, and it's control shortcut. See, things I don't ever use. Um, anyways, let's compile this. Um, link, compile, download, and what we're going to see is the whole program being downloaded. The purpose of the capture window is to capture all the communications between SigmaStudio and the part. Well, I kind of lied. It's not quite all of them because when you turn on a meter, it's reading every 10 milliseconds, and that would fill up the capture window rather quickly and make it useless. So it filters out those continuous readbacks um, on a readback cell or the meter cells that are by default continuous readout. Um, it'll filter those out. So it's not quite showing you those things, but everything else it shows you. So let's link, compile, download. And boom, we got a lot of data here. This part is a lot bigger than the old 1701. So the first thing it does, you can see what it's doing. It's doing the SPI toggle, which sets it into SPI mode. The serial port, because the communications port, I should say, um, it defaults to I2C when it powers up. So you set it there. It does soft reset, uh, changes it from 0 to 1 to do a soft reset. Waits, hibernates, does the sets up the PLL, waits for it to lock, then sets up a whole bunch of registers. And then finally, it starts sending the program data. And these are all block writes. So 824 bytes of program data as one big block write. And then we have the DM0 data and DM1 data. So those all three memory banks get programmed and as large writes. And then there's a few little housekeeping things to restart the core and then start it running and take it out of hibernate. Um, yeah, and so it shows you exactly the startup procedure. You can, if you want your DSP to do the exact same thing, your controller, you could literally click on the bottom here. You cannot use Control A to select every single line. I wish it did, but the programmers did not put that in. So I have to hold the Shift key down and click at the top. So I had clicked on the bottom and then I went up to click to the top. Or I can click on the top and go all the way to the bottom and Shift click and select them all. Then we can right click over this and you have a bunch of choices. You can copy to the clipboard, you can save it as text, you can save it as raw data, in binary or as text files, address and data, etc. Register control file. So all these things can be done if you really literally wanted to capture it. And you can also send it to the sequencer. Sequencer? What's that? Sequencer is this handy little function we have in here that's fairly well hidden. You have to know where it is. And if we look at this capture window on the far right, you see this double arrow. Display sequencer window. That's where it's hidden. Don't tell anybody. All right. So I click on that and it opens up the sequencer. Very handy. We can set up like macros. It's basically like a macro generator. We can set up a bunch of commands with the data we want, and then dump it all to the DSP at one point, at one time or another, and that whenever we want. And that gets captured in the capture window as well. You're going to see it. It's just as if you had an aardvark or something that's writing to it, or a microcontroller that's writing to it. But it's built in right here. It makes it handy. But before we delve into this too much, let's look at the params window. So in the capture window, we have a tab down below here, output and params. Params is short for parameters. And so this will allow us to look into the actual memory in the DSP. Handy little thing. You can see all the objects. By the way, when we compiled, again, you can see the objects. Tone 1, level single. These are the volume controls. These are usually the names. See, single 1 on the volume control here in the schematic is going to be single 1 right there. So it tells you how many MIPS it uses, etc. And then you can find it by the same name in the parameter name column. And I usually like to expand this because some of these names get long. Did I do this right? Param name. And then cell name. So the cell name and the parameter for that cell. So this gives you a clue as to what's going on in the DSP, and you can also see how to control it. The data, before I get too much further here, these other columns, which is very handy, is the data in these memory locations. So here's the memory address. So an address memory 0, right now we have a 0. But let's go up where there's actually something in here. 16, has a number 76 or a hex 4C. See, this is all the same data. It's not three different pieces of data. It's just looking at the same data in three different formats, which is extremely handy because sometimes you just want to see the hex. Sometimes you want to see it as an integer value, or sometimes you want to see it as a fixed point with the real portion. Um, so very, very handy. It depends on the object. It makes it very usable. The address, as you see, is in decimal. That's what it defaults to. Uh, what can I say? It is what it is. Um, you can you don't have to live with it though. You can right click and say address and hex, and it'll process it, come back, and then eventually will spin a little and then come back with the addresses and hex. There's a lot of memory in these parts, so it takes a little while. And sorry, I hope I didn't click on something I shouldn't have done right now because I'm using this recording software, which is really putting a heavy load on the computer. Um, yeah, I got a feeling I shouldn't have done that. Shouldn't have done that. Um, so the things I want to talk about here. Let's look at what the memory, what the data is as soon as this wakes up. So this might need some editing. This is not good. Very not good. So, but meanwhile, can I talk about anything else? Probably not. Yeah, no, I can. The DC cells actually holds data in one memory location. It's in the DSP. So we're going to be able to see in the capture window in a minute, in the params window, what is actually in there. Finally, it's in hex. So it's called DC1. So let's go looking on the cell column here for DC1. Oh, we get the tone, that's the oscillator, that filter I put in, single level, etc. Well, DC1 right there. And here you see we put a value in 8.24 format of 1. There's the integer value of 1. And of course, you can see it in hex that the 1 is way up here. The integer value is displayed in decimal. So that's why this is so good. Saves you from typing in a lot in the calculator. There is a refresh key here, which allows you to reread this stuff. So I can hit refresh. And if it didn't change, it's black. If it changed, it's red, which is very handy because we didn't change that at all. If I come in here and I say 2, since SigmaStudio knew I changed that to a 2, it went and changed it here to a 2. So now the value is a 2. If I do a read back, we're going to see 2. If I do a refresh, it's still going to say it didn't change. But let's show you how you can control this with a microcontroller. I'm going to take this, this line. It's already selected. That's the problem. Okay, select that line. I'm going to right click on it and say add to sequence. So I'm going to add this to the sequence. Now, you can always add an object into the sequence directly on your own. You can say add item, a read, a write, a delay, whatever you want to do. But it's easy enough just to copy it over. And so I'm going to change the data. Instead of a 2, I want it to be a 3. Yeah, why not a 3? And that adds this item into the sequencer. Now, to actually send it, and I'm going to go back to the output port, clear this off so we can see. Now, on a sequencer, download mode to hardware. These are called modes. I'm going to go click, and you see the command. It did a block write, 4 bytes. It sent a 3 to the address 4B. Well, the address 4B is this address of the memory, and as you see, it is now a 3. Voila. And up here, though, it still says 2. because SigmaStudio here in the schematic has no idea that this command from the sequencer happened, that something was sent to the DSP. So it doesn't know that it's no longer a 2. If I do a read, it's going to read 3. Voila, it read a 3. This still says 2 because it still thinks there was a 2 there. So yeah, we're kind of fooling it. We're going under the hood here and making some changes, and it doesn't know we made the change. But the readback, this also demonstrates that the readback comes from memory up. It's not in the host PC. So this is why it's a good comms check. So let's work with these modes. Okay, we set it to 3. Let's say if we want to play with a few other values. So I'm going to say add a mode. I did a right click there, by the way. Add mode. So mode 0, we had this command. I want to do the same thing. So I'm going to do command copy. We can also right click and say copy and paste. I'm going to go to mode 1 and I'm going to paste it in. No, it didn't do that. It did something very different. It did that because the paste command. Oh, wow. That's not good. Messed up my project. Okay, we're gonna fix this up. Okay, my undo. There we go. My undo worked. Okay, where was I? I was down here trying to do this and I ran into a bug. Copy. Go here. This time I'm going to do paste here. And I know that one works. I was interested. The cut and paste buffer had something different in it. But your link compile download again here. Output's not something's not connected. Oh, it still thinks there's this thing here is in there. That's why there's an issue. Okay, we're back to normal. All right, mode 1, mode 2. So now I can change this mode 2 to be another number. So let's say it's 6. I like number 6. So I can download this. It changes the data to 6. I can read this back. It reads the 6. So I can go to mode 1, mode 0 I should say, download that. It should change it to a 3. It did. So say I can continue to do this. It's a great thing. But mode 0, mode 1, kind of hard to remember. So you can rename these. You can say DC to 3. And then I can rename this one DC to 6. And voila, I can, that makes it a little more user friendly. Download that. And when you save, you have to save it before this next thing will work, the sequencer window. So I'm going to save this sequence file, and this will be an XML file. It's going in not the place I want to. No, where am I going? Documents. Sorry. I want to go into these videos and video. Okay, fine. And we're going to give this a name, XML sequence file. And you see it's going to save it as an XML file, save. You can save it as other file types too as well. So now once this is saved, I can click on this launch sequencer window. So when I click on there, it opens up this window with these 2 modes already in there. Now all I have to do is click once on the button. Click DC to 6, it changes it to 6. We can watch right down here. DC to 3, it changes it to 3. So very handy for doing like larger macros where you might be changing filters and changing settings, something along that line. And it's just parameters, of course. And it'll download it in one click. And you can click between a couple different settings or to compare between them if you like. Although there is another feature that does this in the Sigma DSP, but that's another video. I mean, in SigmaStudio, but that's another video to discuss. So where else are we going? Let's look at how some of these objects work. I mentioned that this Params windows allow you to do this. Tone, gain, there's the gain number. This is going to be, I can turn on the meter. Let's say turn on the oscillator. Yeah, yeah. Watch, I'm going to turn on the oscillator. Click. And I hear the tone, which is annoying, so I'm going to mute it. Boom, I'll mute it. But the meter's going. And obviously I can change the level and you can see it change. All right. I'm going to set it to 0. Now this level I can go in and change, but that's this parameter here. So I can directly go in here and say, no, I want it 10 dB down, or 20 dB down, whatever, 0.1, 20 dB down. See, the meter went down. And it's a gain factor. If I say 0.5, it's going to be 6 dB down. And then back to 1. Now I could obviously enter it in here. In the GUI, it does the translation for me. If I say -6, it's going to translate, the GUI in the SigmaStudio will translate that to a gain factor and download that to the DSP. See, 0.5011. It did it as a gain factor. We can see this on the capture window. Safe load right, 0.50118. So we entered -6. It downloaded a 0.5 because it does the calculation for gain factor. That's what your controller will need to do. It will need to do that calculation. You might have a button or enter data however you're wanting to, but it has to change it to a gain factor. So the same thing, and go back to 0. The same thing with the volume control that's next to it. I'll go to Params. What's the name of this volume control? Single 2. So we've got to find single 2. There's single 1, single 2. This one has no slew. So all it is a simple gain factor. Again, I can drop this down 20 dB by just putting in a 0.1 and watch the meter. Boom, it drops down or 20 dB. So we can enter in the parameter, and that's what your DSP would do. Actually, I want to keep that one at 0.1. Remember I said it's at least 20 dB down is good. Now, this other volume control, single 1, has slew in it. So let's go look at that one. Where was single 1 again? Single 1, look, there's 1, 2, 3 different parameters that have been exposed by the programmer that you can change. The slew mode, this has the hardware slew, a lot more complicated, more than I want to get into right now, but it's the mode of slewing up and down, what kind of curve and that sort of thing. So the slew mode, target, and the gain. So if I do a read here, I could see the gain is a 1. Target, you don't want to write directly to the gain because that's like the current gain right now. You want to write to the target to use the slew. So I'm going to say I want this to be -20. It will, you download that to the target value, and then it will slew it from wherever it is to -20. So I could enter this in obviously right here saying 0.1, and we're going to see the level go down in the meter again, even another 20 dB. And go back to 1. Or I can do the same thing with this volume control. I'm going to right click and say -20. And watch the target's going to change. Well, you're probably not going to see it because it does it quickly. But 0.1, and we don't see this gain. We have to refresh. Wait a minute. Is it complaining to me? Why is it complaining? Good question. Oh, it's doing it. Okay. Anyways, we see the level going down, and we see the target. We refresh, and it says point 0.1, and the gain. Well, why is it still saying 1? There we go. I guess I didn't actually click refresh. Um, I must have missed it. But you see, it went down to point 0.1. But the we let the gain control do it. So if I go back to 0, watch down on the params window, you're going to see the target change back to 1. See, because that's what's getting loaded. And if we looked at the output, the capture window output, you're going to see that if you looked at the address, 2D is where it's writing to, and 2D should be level single 1 2. Where's single 1 2? I moved single 1 2 2D target. So that's the memory address it's writing to. The meters, these meters do some summing in the DSP, and and you only read it out periodically. And so these level meters, you're going to see a time constant, a hold time, and a decay time for the meter, for the ballistics of the meter, decay, that sort of thing. Some of that is done in the GUI in the PC, the host computer, but some of it is pre-done in the DSP. Um, the whole time you can see here, its value is 480 in integer format, and so if you stop and think about it, the only way the DSP knows to do timing is with sample rate. And so the sample rate is set to 48K. And so at 48K, 480 samples is 10 milliseconds. So it will hold its value for 10 milliseconds before it starts to decay when it gets the peak value. So if you read the meter every 10 milliseconds, you're not going to miss anything. And that's the purpose of that. If you want to read it a little more slowly, you can change this delay time, and it's in samples. Um, this is another example that looking at it in 8.24 format doesn't give you much information. 2.86, what? Huh? I can't understand that. 480, now it makes sense. It's number of samples. Um, the filter, we have 5 coefficients. It's a biquad. B2, B1, B0, A2, A1. This is for another discussion. I had it set to no gain, so the coefficients are rather simple at the moment. A 1 and then the rest of them are all zeros. Uh, but if we were to come in here and change this, you're going to see these coefficients changing. Boom. See? They're getting downloaded through the capture window, and that's what your host controller would need to do. It would need to know how to calculate the coefficients and download it. We do have coefficient calculating filters that because the Sigma 300 is so powerful, it can actually calculate its own coefficients. But this basic filter, if you're running low on MIPS, this one is very good to use, and it's a legacy from all the other Sigma DSP products, so it works all the same. Tone generators, again, this is all dependent on sample rate and the period. Uh, yep, yep. So not too much to mention about this as far as the frequency. Um, what else can mention about these objects that's kind of cool? Filter states. The mute. Remember I muted this? Oh, let me actually mute the oscillator so I can unmute the mutes. And you see it changed to a 1. This one works a little bit differently. It just takes the state and calculates the gain factor from that. So this one works, it's not quite like a volume control like the older Sigma DSPs. It was basically a volume control that you can just send a 1 or a 0. This one's a little bit different. Um, and index here, this tells you where the switch is, whether it's on um, 0, 1, or 2 or 3. So it tells you the beginning channel of the stereo mux, 0 or 2. And so that's, again, just a pointer. Um, but that can be changed. You can change that with your processor. Um, well, I think it's enough said here. We got a really good idea of how these basic windows work and starting to see how some of these parameters and some of these objects are working. And we can take this and run with it. Uh, yes. Enough said. Have a great day. Keep watching. I'll try to make more of these interesting videos, hopefully. Have a great day.